CBE 140 Final Design Project. Featuring Avanie, Alvin, Ishaan, and Michael. The system used in this experiment was 60 milliliters of orange juice filled into a beaker. The beaker of OJ was placed in another beaker full of water, kept at a constant temperature of 47 degrees Celsius. A hot plate with a stir rod was used to keep the temperature of the bath constant. The water bath acted as a constant heat jacket for the system. In Part 1, conduction and convection were studied in the system. The thermometer was used to mix the orange juice in Part 1 to cause convective heat transfer. We assumed ideal mixing and no heat loss to the environment. Temperature readings were taken every 30 seconds for a 10-minute period. A second thermometer was used to ensure that the water bath temperature was maintained. In Part 2, only conductive heat transfer was studied. There was no mixing of the orange juice. Temperature readings were taken every 30 seconds over a 10-minute period. By solving the energy balance for our system, a linear relationship was found between the natural log of our temperature points and time. For both trials, a linear regression was used to determine the slope of each line, which was proportional to the heat transfer coefficient times the area, divided by the mass and specific heat capacity of the orange juice. The area of our boundary was assumed to be a perfect cylinder. The heat transfer coefficient in trial 1 and 2 were determined to be 99.04 and 71.23 watts per meter squared Kelvin respectively. And now for a little bit of fun!